Hello, everyone. Welcome to another weekly Wednesday winter webinar series. I've run out of W's now. Today, we're going to have a look at Brainsight, the Neuronavigation software. We're taking a quick look over kind of some features that have been added over the last 12 months, and then a closer look at the SimNIBS integration as well, so the current flow modeling towards the end. Before we get going then, for those of you who are yet to attend one of these, we always do a quick kind of introduction. My name's Mark Crawley. I've been a product specialist at Brainbox now for 3.5 years. My kind of typical remit within the company is assisting those new or new users or users who have come back to a software like Brainsight or the hardware side of stuff, so TMS or TES, assisting them with kind of getting going with it. So if they were to purchase it, I would visit them with the equipment, do the installation, do a bit of training with them as well, making sure that everything is kind of running smoothly. More recently, obviously things have gone online, so those installations now are done like this, which has posed a new challenge, which is a lot of fun. And then obviously online we have our conference, which we kind of helped out with, some workshops which we'll be bringing to you, and then the standard kind of after sales support as well. With me today is application specialist Rory Cutler. He doesn't need much of an introduction.
Oh,
I have no doubt he will brief you all very quickly on who he is.
yeah, so I'm the application specialist here. I mainly deal with software-related things, but more recently I've been dealing exclusively with transcranial focused ultrasound. I was a researcher at Kubrick 3 years ago, and now I'm very much involved in day-to-day activities similar to Mark with the Brainbox initiative and supporting and selling products. There you go.
Lovely. Okay, let's get things going. So before we get into the real kind of nitty-gritty, let's give you a quick overview of Brainsight as a system, like what it is. So it's a software which kind of takes its roots from neurosurgery, so the frameless stereotaxy. So without having to physically clamp a frame to someone's head, it's that kind of image-guided type approach. So obviously other applications for the kind of frameless stereotaxy became available or began to emerge. So with TMS being one of the tools which we can guide with the images. Brainsight 1 was first introduced not as a commercial product, as more of as a project of then researcher and now president of Rogue Research, Rock Como, to help his colleagues in McGill University. Obviously, there was Rock saw something and ran with it, and in 2001 incorporated Rogue Research, the company, which now makes a whole host of other non-invasive brain stimulation tools and products. So the CTMS, the NIRS, an upcoming robot, all sorts of things that they do. And then 10 years after it was first introduced, we saw Brainsight 2, which was like a big leap forward. There's all sorts of features were introduced in Brainsight 2 and a complete overhaul of the software graphics itself. So it looks a bit nicer than it did in Brainsight 1, which is some of the graphics we've got there on the right-hand side. We'll be taking a look over, like, instead of since its inception, we'll be looking at like the last kind of 12 months or so in more detail. So 2019, we saw Brainsight 2.4, and in 2.4, we saw a whole host of NIRS features added. So Brainsight NIRS was always capable of doing NIRS acquisition, but then now the analysis of that data is now capable within Brainsight. But a little bit before, in 2007, there was something called stream to file, which was added to the online session. This allowed us to export in real time the location of all the trackers and all the calibrated tools as well. But in 2019, there was kind of snuck in that 2.4 release as well. In 2019, there was a load of updates made to that stream to file. So now that stream to file logs when a target changes, when a TTL trigger occurs, when a sample is created, and obviously when the crosshairs move as well. In December 2019, so obviously the Rogue research team were very busy in December, well, the run up to December 2019. Any sliders that you see in Brainsight, be it for moving the image around or for adjusting the thresholds of anything, all of those sliders now have text boxes, so you can type in the exact amount that you like, instead of having to slide and get there kind of on a mouse wheel or anything like that. The manual method of kind of in the Atlas spaces has a different method now. It used to be a green box, which once you got your head around it, was intuitive, but it wasn't necessarily the most straightforward way of doing it. That method changed then in late 2019, and now there are green lines that we drag, which kind of bound our coordinate space over the structural image that we'll be using. All of this will make sense when I go ahead and show you it in the software itself. Another nice feature, the keep largest piece button. Again, these are all kind of really subtle things that no one makes a big song and dance about. So here I am making a big song and dance about it. So when you go ahead and upgrade, there'll be all these nice little kind of subtle features that will make your life easier. But this keep largest piece is mainly using the reconstruction side of things. Sometimes we see with some data, that kind of structural data that's been imported, there'll be some weird kind of floating bits and bobs. But this keep only largest piece now allows us to kind of tick a box and remove all of those floating bits and bobs. So then we're just left with some really nice, clean, like structural head model data. And then I don't know when it was introduced. I think it was in there before I started, but on the bottom is snap to, and it means that when we create a grid, we can snap those grid nodes to our curvilinear brain. Previously, we had to use a curvature slider, which snapped those grid nodes around a sphere. Obviously, we know that the thing we're snapping them to, the curvilinear brain, is not a spherical object. So we always had kind of some grid nodes where in the middle of the grid, they would be perfectly kind of tangential to the surface. But those ones on the kind of extremities of the grid would then be, not quite correct. But now this snap to tool, which is the most kind of simple little button, it's great. It means that all those grid nodes are snapped correctly to the surface that we're going to be stimulating. More recently then, in 2020, earlier this year, we saw the beta release of Brainsight 2.5, which means now that we can do some current field modeling. There'll be a lot more in this later on, so I'm not just kind of brushing over a seemingly massive project. October 2020 saw SPM12 MATLAB file collaboration or incorporation. It means now that anywhere that like an XFM file could have been loaded, the SPM MATLAB file can be loaded too. Typically, we use this for kind of Atlas space registrations. And two other kind of really nice features, which never maybe got the time they deserved. Optimize Now is a great little button for the crosshairs. If we were doing something on a clicked surface, so not necessarily on a 3D model, the trajectory that we were stimulating at wouldn't necessarily be correct for the where the coil will be sat in real life. So that if we were to stimulate without optimizing, we'd have to hold the coil at a really crazy angle. But now we have this optimize now button, which means that instead of, there was a workaround where you would click in the middle of the crosshairs on a different window and it would orient the coil correctly. But now we have this optimize now button. So there's no option for error to be introduced when we do that. And earlier this year then, we saw these adhesive subject trackers as well. So instead of now, we used to rely on the headband or the glasses. We now have these adhesive subject trackers, which use two just kind of button press recording electrodes. They click on the back of the subject tracker, and then we can go ahead and then place that anywhere, kind of, anywhere on the forehead or on the cheek or something like that. It means it's a little bit more flexible than just having to rely on those two previous methods. Okay, so current flow modeling. Before getting into it, obviously there were some challenges that we faced before we could incorporate it, and some questions that needed to be asked. It's hard work. It's not the easiest thing, current flow modeling. And then should we bring that into a Neuronavigation software, we have to decide why we would choose one over the other. So, we know already MRI access is not the most accessible for everyone. So expecting then a TMS user to segment each brain that they scan might be a big ask. The computational burden of doing that is hard work. To this day, we often still leave our laptops on overnight in the office, or a desktop running overnight. We come back and it's been segmented. That's getting better as computer hardware gets better, but it's still a long time. And then obviously there's a whole load of different ways of segmenting the brain. There's a few different models that do it, but we would have to pick one over another. We don't really have the ability to implement a load of different models, because then softwares become massive. So we would have to choose, or we'd have to be biased towards one. And then if we were biased towards one, why are we biased towards it? That model then would have to be validated. The one we choose would have to be validated. And how could we be confident of the results that we got from the segmentation? So the research team chose to incorporate SimNIBS. Why SimNIBS? Well, because it's a peer-reviewed current flow modeling. So we know that that it's open, or questions can be asked of it by researchers, and it's that kind of validated model that we're after. But also, what inputs are we using if we're doing the stimulation? So more on the stimulation side stuff. What inputs are we using for the magnetic field? Do they stimulate based on geometry? How do they measure each coil individually? Do we have a representative coil, or do we have kind of individual coils for every single coil in existence? And also, does the model that we're using to segment do different, take into account those different conductivities of each tissue? If they are taken into account, are they taken from subject-specific MRIs or from one given standard head model? So to this end, SimNIBS is the one that was chosen, given that it's open source, developed by Professor Axel Thielse in Denmark. Those E-field measurements now are still done by SimNIBS, but the GUI, or the visualization, takes place in the really nice kind of Brainsight software. It opens that kind of black box that other manufacturers have, because field modeling is available in other Neuronavigation products, but it's a bit of a black box. No one knows, what the algorithms are being used to do so. It means then that in Brainsight now, we can, prior to stimulation, we can run a reasonably quick simulation to see which of our proposed targets is going to yield the result that we are after. It can also be done retrospectively. That's possibly something we can touch on a little bit later. So without further ado, let's go across to the software itself. So the software all looks the same still. Some of those quick features we can look at really quickly, we have down here. So in doing that manual AC/PC scaling, this used to just say from XFM or from, but now obviously now we have that .mat. So here it is here. I'm not going to import this because it's not correct for the data set that we're using, so it would look wrong. But it's now an option. In reconstructions, then the Brainsight SimNIBS version loads everything for us. So all these reconstructions are already taken care of for us. The only thing we have done extra is added this Brainsight skin, because the SimNIBS skin is a little bit kind of rough. It looks a little bit like it's been made out of Lego. So we've got this done as well. But one of the other features we can look at just here, when this loads, obviously. Are we going to get there? Or are we going to be tripped up? While this is loading, Rory, do we have any questions we can field so far?
We do, but it might be good to show this in action as well, in addition to answering it right now.
Okay.
And it's regarding optimizing the orientation of the coil using the optimize button the one you mentioned earlier. Okay,
cool. Yeah, we'll take a look at that. We'll make a new target we'll have a look in the targeting window. But this keep only largest piece button is in here now. We're able to see this. So again, it's kind of a little subtle thing. But here it is. If you did have some kind of floating artifact, up here, ticking this would eliminate that and keep our head data. For those of you wondering who this glamorous assistant is, it is application specialist Rory Cutler. Okay, so going through then to the targets window, we can have a look at kind of these simulated E-field projections. So setting the targets are the same. We still define a point on a head. So I've got something on the right hemisphere here. And then we either do a single node or we can do a number of nodes and then go ahead and simulate them. To do it, so typically we might get tripped up here with, it's looking okay. So typically this would be our interface here, where we just manipulate the grid as we always did. Now, when we expand the grid and click on any one of these nodes or highlight all of them, we can see that we have this. So we have stimulation strength, the TMS coil. There's a whole host of TMS coils in here now. These continue to be added. So if you have a specific coil that you use that you'd like to see, get in touch with the guys at Rogue Research and they will, I'm sure, be, they'll do their best to incorporate it. Obviously, it needs to be measured somehow. Once that's in there, we can then compute simulation. It takes about 4 minutes. The accuracy is correct as well. It's not anything that's optimistic. It's not a slow 4 minutes or long 4 minutes. It is about right. And then once those have been done, we can then open this here, this inspector window, and then we have a new E-fields option within this where we can see we have all of these grid nodes and we have the volts per meter. That looks tiny because at the moment that is measuring from where the green cursor is. If I move this over here, we'll see that number changes then. So in doing this, we want to select these thresholding figures here. These want to be the same for all of the different grid nodes. So we're keeping something as a constant. But as I click through the grid, Oh, here's another feature request then that I haven't mentioned as well. Instead of now clicking through the grid, we have these arrows here, these up, down, left, right arrows. So now we can navigate through the grid using these arrows here. It is just being a little bit slow. But as you can see, the E field changes depending on which grid node I'm taking a look at. Okay, so in answer to the question that we had just a little bit earlier on, as I move around here on our grey matter, you can see that there's an optimization taking place. But if I was to go somewhere like here and click, we can optimize based on the thing that we're going to be working on. So typically it'd be Brainsight skin. But if I was to be on the grey matter, then you can see this optimize now is going to be a little bit different to what we would have for the skin, because we're not going to approach it at that first angle. Was that the question, or is there a specific question around that? Again. Okay.
Sorry, I had my thing muted. They're asking, I think they're asking about the orientation of the coil handle in particular when you're optimizing a trajectory.
Well, that would depend on the structure that you're stimulating. We know that, you know, for the motor cortex, you want to be perpendicular to the structure that you're stimulating. That then can be changed using this twist slider in the top right. Also, because now this is a slider, you can see at the bottom, although it's quite small, we have this angle here. So 135 degrees, there or thereabouts for the motor cortex. But yeah, that's where this can be optimized. I guess if I was to preempt the question, the angle of the coil handle is not optimized. That should still be done automatically, or not automatically. It should still be done manually. So you should optimize your own orientation of the coil handle. But yeah, as you can see, as I move this around, you can see we have different volts per meters. So we could say that for this 3x3 grid that we have set up here, it appears that the middle grid node is the one that we want to stimulate. So if I go across and down slightly. There we are. So if I move this guy out of the way, the area that we'll be stimulating then, zoom in, is the best activation underneath that grid node. So going back to the slides quickly then, where might we be going in the future? The guys at Rogue Research, particularly Rock, has already demonstrated there's a Brainsight robot. It was a prototype for a while. It's still a prototype, but now it's kind of nearing its final version. It's great. It's a much smaller approach to robotics than we've seen for TMS already. So it's hopefully a whole lot more accessible in terms of space and price. A full release of Brainsight 2.5. We don't have a date on that yet, but it's in the works. Obviously, you can see it's already working, so it is coming. And then with that, then we'll see further developments of the SimNIBS integration. So with the inclusion of TES modeling. One important point on Brainsight then, we already know that Apple have released their new macOS Big Sur. If you are a Brainsight user, it's vitally important that on the Brainsight Mac, you don't yet update to Big Sur. There's something in there that Apple have done, which means that one of the internal drivers kind of renders that Polaris Vicra obsolete. It won't work if you update. So obviously, we in Rogue Research are aware of this. There is a fix coming, but unfortunately, Apple beat us to the release of this. So Brainsight 2.4.7, I can't remember what the current version is. 2.4.7. Let's go with it. It is on the way. It'll be here in the next couple of weeks, maybe the next week. That then will contain the fix that we need. Once that's released and that's your Brainsight version, then you're then good to go ahead and update to the new macOS fixer. Okay, so that is a whistle-stop view of current and future developments in Brainsight. If there's any questions you want to pose, anything specific you want to see within Brainsight, by all means, now is the time to pop your virtual hand up and yeah, let us know.
We have a few questions. One of them I'm in the middle of writing an answer to, but I'll stop and I'll just broadcast it instead.
Okay.
So one of them, which is related to when you chose your little grid earlier.
Yes.
How did the grid center get chosen?
The grid center is chosen. Let me exit this again. So as I move this green cursor around here, the grid center will be wherever this is here. So if I back these crosshairs off, you can see we have this kind of little node here. This here will be the center of the grid. So it will expand out from the middle of the grid here. So this, for example, my 3x3 grid here, this green crosshairs was over here like this. So that is how the center of the grid is chosen. Yeah.
And then this one, I tried to answer it myself, and then Rox actually got a very cool answer to this, but I think people have been kind of screaming out for a while now.
Cool.
Regarding SimNIBS, can you simulate the E fields only for the standard definition files? Or, as in the case for SimNIBS, unless you have a special core definition file? Or does a simulated field depend on the actual coil position?
And what was Rox's answer?
No, you answer this one now, and Rox's answer is that they've actually got an in-house device being debugged that can you can get any coil in-house, and they can give you the E-field measurements from it, which is answers a lot of questions and helps us out quite a lot.
Cool, yeah, definitely. But yeah, I thought Rox's answer superseded mine, which it does to an extent. So yeah, at the moment there is these in here at the moment. I don't know how these have been done. We have done some work with Professor Hartwig Ziebner and with Axel Theatre as well to do some modeling of some coils. So that's how they were done. Whether or not Rock used his new device to do the rest of these is a mystery to me. But yeah, these measurements are specific to coils. There's also a great paper. Well, I can't remember who it's by right now, but it's a good reference. I'll find it and I'll share it. It's a good reference for how to calculate what this stim strength is, or how it's going to be, relative to the stimulation strength that you're using. If not, use this figure that's in already. Use the default figure and just use it as a reference.
Okay. Let me just recollect my thoughts. Okay. This kind of relates to the one you just answered. But if you use the coil in a non-conventional way with the stimulation center at a different location, for example, if you're stimulating M1 with the right wing of a figure of 8 coil, would you need a new definition file?
Yes. This would assume at the moment that you are stimulating from the hotspot. You can see kind of here on the Brainsight skin window here. This assumes obviously that you're stimulating from the hotspot of the coil. We'd be stimulating over the left wing or the right wing. That hotspot then would be shifted either left or right as well, we'd imagine.
Yeah, I think that the coil definition files, I think they make measurements from a range of places on the face of the coil. And that's what determines the field distribution on the scalp. But I don't know if you can move the center of that point to one of the windings, whereas in this, it's always in the middle of the coil itself in the hotspot.
There's maybe some behind the scenes trickery can be done.
Yeah, I reckon you could probably figure something out. Does and can SimNIBS take into account coil orientation when simulated E-fields? I did answer this saying yes, but I thought it'd be good to show it as well, as it's one of the highlights of being able to use SimNIBS in Brainsight.
It does, yes. I'm not going to do another simulation now because there'll be 4 minutes of me talking aimlessly at people trying to fill the air. But yes, it does. If I was to move this coil through 180 degrees, we would see a different field. So it does take it into account. And if you've used SimNIBS as well, on its own outside of Brainsight, you'll see that there's a certain view you can do in SimNIBS, which gives you directional vectors for which way the current is traveling across a structure. So yeah, it does take it into account. And obviously it's very important.
Yeah. And then there's a question about where you email to request specific coils. And I believe that is support@simnibs.org for now.
Okay, yeah. But also you can get in touch with us. We'll forward it to the right people. So support@brainbox-neuro or support@rogue-research. All of those email addresses will get you eventually to the right people.
And then there's one which I answered in the questions, and it's where and how do you perform MRI segmentation? In the questions, I have put a link on that contains documentation on how to segment an MRI scan in the terminal on Mac, Windows, or Linux.
Cool. Yeah, I should have made that explicit. Segmentation is not carried out by Brainsight. It's assumed that the user has done it previous to using this. Brainsight then just loads those segmentations, and so the maths is also SimNIBS, but the visualization is Brainsight now. But yeah, Rory's your man for asking that question. There is also somewhere a guide if you want to use this SimNIBS beta version. We have I'll dig it out and send it to anyone who would like it. We have a guide for installing SimNIBS and Brainsight. So you can see here I've got 2 versions of Brainsight open. So instead of this beta version overriding your standard version, there is a guide that we can send out, which lets you have the 2 open, kind of all running side by side.
So there's one now. Is it all right if I answer it, Mark?
Be my guest, yeah.
So somebody's asked, what MRI data do you rely on? For TMS, it's okay to use, like you can use a standard T1 because the magnetic field will travel through the skull, scalp, cerebrospinal fluid relatively unhindered. And that's what Mark's using here. There's actually, for current flow modeling with TES, there's actually recommendations in a paper that I'm just broadcasting to everyone. And that there's, for very accurate stuff, particularly for TES, it involves doing a T1 and a T2, and the T2 is included to improve the contrast between skull and skin. And that's Nielsen et al. 2018 in Neuroimage. That is in the Q&A now.
On that as well then, Rory, we could also add that the Mickelson 2018 paper, maybe, which also there's something to bear in mind when doing TES simulations, is the position that someone was scanned in. Typically, someone will be scanned lying down, and they'll be stimulated in a prone position or sat up. That difference in how the CSF lies moves current a little bit differently, and there's a difference of like between 5 and 10%. The paper's on the forum, so you can view it there, or I can send it. If you want to get in touch with me, Mark at Brainbox-Neuro, I can send you it directly as well. But it's just a little bit of food for thought.
There's one more now. Let me just filter through. Do you have a recommendation for the type of Mac PC? They're using a beta version of Brainsight on my PC, and it works slow with SimNIBS. That might just be because SimNIBS takes a bit of time to do this, to run the simulation behind the scenes. But I'll let you answer that in detail.
Yeah. In terms of, so Brainsight is only Mac, is only written to Mac. So for this, as long as you've got something with a lot of processing power, so we all use MacBook Pros, or an iMac with a good amount of processing power, and at least Mac OS, I believe Catalina is the oldest one. That might have changed. I'm sure, Sean, if you're in, you can let us know if that's still the case. But yeah, in terms of operating system, it used to be at least Mac OS Catalina, which is quite an old one anyway. But yeah, a MacBook Pro ideally, or a good iMac.
Here's another lovely question for you now, Mark. Do you have any plan to include coil definition file for DayMeds coils, air cooled or the standard coil?
Yes.
Yeah,
we do. We're working on it, and it'll be in there as soon as we can get it done. But yeah, it's
fantastic. The world is a better place. This question now, I can see the answer directly in front of me on the screen, but it'd be good if you could point it out. In SimNIBS, you need to fill out DI over DT for simulations. We're big fans of DI over DT at Brainbox, as it's the most accurate way to, and the only accurate way to calculate the intensity of a coil. Do you need to specify DI over DT in SimNIBS in Brainsight as well? And
yeah. So if I wiggle the mouse around here and highlight this, yes, you do. If you don't have it, like I said earlier on, use this figure in here as just as a reference. But obviously, if you can put in your exact values, you're going to get more accurate models. So.
And then I think that wraps up all the questions. Rock has pointed out, I've seen on the technical side of what the computer has. It says SimNIBS can have multiple cores CPU. So the more cores and the most RAM you can afford, 32 GB is good, and that would speed things up.
Cool. Thank you, Rock. Okay, so that, yeah, like Roy said, that pretty much wraps things up. Unless, I mean, if there's any last-minute questions you want to get them in now. Going forward, then we have another one. We have another weekly winter webinar happening next week. So I'll be taking a look at the NeuroStim TES. Again, some kind of new features, new bits of hardware which are in that. And then we might schedule another one before Christmas, if we have time, if the demand is there. If there's anything particular you would like to see, by all means, get in touch, let us know. But yeah, short of that, thank you very much for attending. We'll hopefully see you soon. If we don't see you soon, have a lovely festive period, and we'll, fingers crossed, see you at some point in the new year.
Great stuff. Thanks, guys. Thanks, Mark.
Thank you.